Hello, guys. Welcome back to our, homework solutions. In this video, we're gonna do the solutions for homework 10, arithmetic instructions, but this time it's multiplication and division instructions. So this is again one of the straightforward homeworks that we take in this course. Okay, it's just direct application for the information that we explored in the lecture. So let's start. So this is the first question here. What will be the value in AL after the execution of the following code? So you have here 5 lines of code in which we set AL to 10, set H to 10 again, and move BL on 5, move BH on 5, and MUL BL. So it's very important to look at the type of the register, the size of the registers that we that comes in the MUL instructions, multiplication instructions, because we have some cases and each case should be treated differently. So we can multiply word by word, byte by byte, So we need to know the size. So in that case here we say MUL BL. So that basically means multiply BL by EL. Okay, so it's a byte by byte, multiplication. So basically, we're gonna multiply 5, okay, by 10. So again, we're gonna multiply these registers, BL by B and EL. So basically, these are some extra, lines that we will not really need. Okay, it's just to stress your understanding. So basically, when we multiply 5 by 10, the value the result will be 50. Okay. Also here, the outputs or the options given is in hexadecimal. So we need to convert 50 to hexadecimal. So you can just write here on Google 50 in hexadecimal. So it's a 32H. So that will be the correct answer, 32H. Okay, good. So second question here, what will be the value in DH after the execution of the following code? Okay, move AX and 1000, move DX 1000, move BX and 1000, and MUL BX. So in here, again, we need to know, the size of the register that comes in the MUL, instruction, and in that case, it is 16 bits, 2 bytes. BX is 16 bits, so that's basically a word by word multiplication. So and as a result of this, of this multiplication will be stored in AX and DX combined. So although it's one number, the result will be just one number, but this number, since it might be more than 16 bits or 2 bytes, it might be more than a word. It might be stored in 2 combined registers or 2 concatenated registers, we can say. So the result will be in X DX. Okay, so basically X will hold the lower word and DX will be or will hold the higher word. And you can find more information on slide 4 on our lecture. Okay, slide number 4. So what we're gonna have here, a multiplication of AX and X. So when we say MUL BX, since this is since BX is 2 bytes, so 16 bits, that means we're gonna multiply BX by X. So we're gonna multiply 1000. Okay, where is highlight, and AX, which is also 1000. So can say just 1000, 1000, which is of course 1 million. That's really simple. And then again, we need to, we need to convert it to hexadecimal so that we know what will be in AX and what will be in DX. So here is the result. This is 1000 in hexadecimal. Okay, we said that the lower word, the least significant word will be stored in AX, and the most significant word will be stored in DX. So this is the least significant word. 424 is 0. This is 16 bits. So this will be stored in AX. Okay. But the question here is about DH, basically DX, we can say. So basically the higher word, which is basically here just F. Okay. Of course, F is just 4 bits, but you know, the rest will be zeros. So the higher word will be 0, 0, 0F. Okay. So after the execution of this program, you know, or this code, DX will be 0, 0, 0F. So the most significant byte byte, yeah, which is 0, 0, will be in DH, and the least significant byte will be, which is 0F, will be in DL. So the result in DH after the execution will be just 0. Okay. What will be the value in AL after the execution of the following code again? Okay, and of course this code has some, you know, intentional mistake, because here you cannot have, so this is legitimate, move AL and 10, move H and 0, that's all legitimate, but here that's not legitimate. Okay, so div 10 here, you know, is we cannot do that because we cannot have immediate operand with the div or mul instructions. Okay, so basically, you know, the program will stop execution here. So basically, you're gonna have only move AL and 10 and move H and 0. So L will not change, and you're gonna have 10. It will not be 100 because this is not legitimate. Okay. So L will keep its value. One may say Visual Studio is, you know, doesn't compile this basically. So, and since it doesn't compile, so whatever was in AL before the program, you know, before we try to execute the program will remain there, you know, because, you know, the assembler there is, you know, takes the code as a whole, but maybe for other assemblers, you know, other programs, you know, it executes line by line, and that's legitimate as well. Okay, so in that case here, if it's executing line by line, then it will stop at div 10. Okay, but it will not complain for the first 2 instructions, and that's basically was my intention. The fourth question: what will be the value in AX after the execution of the following code? And now we have some division. So basically, I'm moving 99 to AL, move 0 to AH, and move BL and 10 and div BL. So here, this is very important instruction, move AH and 0, because this is, you know, a word. I'm sorry, this is a byte over byte or byte divided by byte, because when you divide the byte by byte, by a byte, you must, in that case, you know, make AH or set AH to 0. And you can find this information in slide 8 in the lecture. Okay, so in that case here we're gonna divide AL by BL. So 99 divided by 10. So that you know, that operation will result in 9 as, you know, a quotient and a remainder of 9. Okay, and basically here, you know, the quotient goes to the quotient, and the remainder will goes to you know, one of the AH and AL. Okay, so if we you know, go back to the lecture and you know, review this, you know, the quotient basically goes to AL and the remainder goes to AH. And remember what we said, when we divide the 99 by 10, okay, 99 has 10, I'm sorry, has 9 tens. Okay, so that's the quotient basically, and there will be a remainder of 9. Okay, so this remainder will go to AH, and the quotient, which is also 9, will go to A. Okay, so basically the number that you're gonna have is something like this. Okay, it's basically 4 zeros and then 1001. This is basically AH, and then 4 zeros again, and then 1001. Okay, so this will be AH, and this will be AL. Okay, after the execution of the, of course, here the outputs are basically in decimal. Okay, so that's basically equal to, if we write it in hexadecimal, okay, 0909. Okay, so we just need to convert 0909 hexadecimal to decimal to hexadecimal to decimal. So this is basically in decimal, other form, yeah. Can just use any website here. It's 2313, which is that answer here. Okay. So let's now go to the last question. What will be the value in AX after the execution of the following code? Move AX on 1000 hexadecimal, move DX 1000 hexadecimal, move BX 1000 hexadecimal, and div BX. Again, it's important to know the size of the registers that came after the div instruction, or the operand of the div instruction, and in that case it's 16 bits. Okay, so we know now the denominator of the division will be 16 bits, will be 1 word, but the numerator might be double word, might be word. Okay, so we need to know, and we can know this by checking dx. If dx is 0, then it will be ax divided by bx. If dx has some value, in that case, the numerator will be the concatenation of ax and dx, divided by bx. Okay, so we're gonna, divide basically once. So here is just an online tool, that you can divide hexadecimal directly. So we're gonna divide the number, which is basically the concatenation of x and dx together. dx is 1000, the most significant word, and x is 1000, the least significant word. Okay, and we're going to divide this by 1000. You can find more information on slide number 14 in the lecture. Then we calculate here, and here is the output, and here is again the decimal output. Look at the decimal output. The decimal output is basically an integer, so basically there is no remainder here. Okay, so that operation will result in a quotient with no remainder. The remainder is just 0. Okay, but look at the number that will be the quotient, which will be stored in AX. This number, which is 10001, is more than 16 bits. More than 16 bits, and we learned that the maximum quotient is just 16 bits. And so the maximum quotient will be basically F, 4 Fs. Okay, hexadecimal, which is basically 16 ones together. And if you have more than this will be an exception, exception error. So you have two, in division, you have two exception errors. When you divide by 0, or when the quotient, is larger than the container that should contain the quotient. So the container in that case is X, but the quotient is basically 20 bits, while AX is 16 bits. So basically there will be an exception error. So AX and the division will not happen basically. So X will reserve its value, so which is 1000H. So after the operation here, you know, X will still contain 1000 X's. Okay, guys, that was it for this homework. Thank you very much for watching and see you in another video.